Hi, I'm Tom and I talk about code. Welcome to another Rust compiler live stream where I'm building a compiler in Rust. I'm not building a Rust compiler, that would be a whole other kettle of fish. Today, we're going to try and build while loops. We have if statements, we have function calls, we have recursion. The next logical step is to have loops, and then I should be able to build just about anything. If I get loops working quickly enough, this will be a shorter stream again today. I want to try and move on to static scope, because I think static scope, in other words, where you have a variable, let's say static int x equals 7, right? And then any place x is referenced in your program. I guess it's also kind of like global scope. I'm going to say, actually, maybe I should call it static. Maybe static's a better word. Maybe global. Let's make a note here. Global? Question mark? But basically something that lives in a fixed memory address, and anytime you set x, you always set the same memory address. This is a concept we don't currently have represented in our compiler at all, so it's going to be kind of important. Okay, let's do it. Let's dive in and see if we can do this. I just need to do one thing first, and then we're good to go. Let's swap over to the correct scene so you can all see my screen and my code, and let's do it. First, I'm going to make a new branch called while loop, and then we're going to jump into our AST. We're going to add it as a statement first. All my statements are defined here, so this will be very similar to an if statement. We'll have a condition, which is an expression that gets tested every frame. Maybe I should draw this first. You guys know what a while loop is, right? We'll have a body, which is a list of statements that gets executed every loop. Every loop, that's it. That's all we need. That's all we need. Okay, so now let's write a parser for it, a language. And it's going to be a lot like an if statement, really. So we'll start with this on our screen so we can kind of see it. Statement, and actually this doesn't need to be, it does need to be an fn, it doesn't need to be pub. Statement while input. So we just have to write out our fun function signature. Okay, so actually let's copy and paste for now. Everything up to the else is good. No else in a while statement. No while else. That sounds a bit too cursed. So now we just have while expression. Actually, I think it's basically the same as an if statement in terms of parsing, right? Because we have it just goes while. Whoa, that was a bad W. Hold on. While expression body close bracket. So that's actually just what this parser does. We look for a token while, we look for a token parentheses, and then any expression, and then a closing parentheses, open bracket, one or more statements that are terminated with a semicolon, and then closing bracket. Cool. And then we can just say, okay. Okay. And we have an AST statement while with the cond and the body. And that's it. That's all we need to do. So that sounds good, right? That's kind of easy. What happens if I try, well, hold on, I need to add it here. Now, I think this needs to go up with if. The longest patterns, the patterns that other patterns may be a subset of, they need to come first. Otherwise, we'll have ordering issues. So that's cool. And is that it? What happens if I build this? Statement while not covered. Well, okay, we need to be able to print it out. So self while cond body. It just goes a little something like this. We probably don't even need the braces. We just say right, not right. I've got H's on the brain. While cond. And then we just do the same thing as before, except we have to have double curly braces because that's how Rust format strings work. And then we do the same thing, which is body.iter.map. Let's put it on a new line just for the sake of this. And then we collect this into a vec of any type because we don't care. Then we join it together with new lines. Cool. Done. Next. Compile block. Okay, so this is the next obvious place where something has to happen. When we compile it, we need to actually do something. So let's say ASD statement while condition body, and let's just panic unimplemented. Cool. What else? What other problems are there? Expressions cannot have generic arguments. Now this came up the other day, and that would explain it. I forgot parentheses. That was probably why I saw this the other day as well. I probably just didn't read my cargo errors quite as well then. Okay, unused fields, but otherwise we generate a real program. So let's look at just a dumb test program where we do this stuff. Let's say while x is less than while 1 is less than or equal to 2. Let's just write just some garbage in here and just see if it parses. Let's go cargo run lang test.code. And we have this same problem where our while statements need to be semicolon terminated. Cool. This is what we expect this time. It says we haven't implemented compiling this yet, so what the hell are you doing? I've got an idea about how to fix this. I'm gonna do it. I'm gonna get there, but we'll have to loop back around to that. So let's just quickly get in the habit of writing a very shitty but at least somewhat useful test case for this. And let's just copy paste what we're doing for if. We're just going to do the simplest possible thing where we try and round trip it. And we'll just say while a greater than 0, this is okay. We'll say, I mean, this is actually fine. Foo is equal to bar, then we return foo. Statement while, cool. Now when we test, something blows up because, oh no. What problems have I got here? New. I didn't run my tests before, and now I'm paying the price. No field memory. m.vm.memory. That's very, very silly. Cond. Okay, well let's put underscores here like it wants because these are unused. It's going to continue warning us that we've got unused things, so we need to state our intent to the compiler. Signal halt. Signature defined here. What kind of we have bound? Function signature. Yes. Signal halt. Where is signal halt? That's actually not that complicated. Let's do this instead. Okay, that fixes that. Now if we make test, VM. Now that is actually correct. But this needs a VM. Gosh, this is just very silly. No field memory. So it should be like this. Should be like this. Load and store not found in the scope because we renamed them to load byte and store byte. So this is cleanup from last stream, unfortunately, that I did not test correctly. Load, let's say load word, load byte. Actually, no, sorry. This test actually tests something, so we need to load word and store word. These expect store word. Excellent machine default. VM signal halt. I don't know why that's angry still. VM Oh, this should be a VM, sorry. There we go, now we're getting somewhere. And if it looks like I'm repeating myself, it's because I copy and pasted a big dump of test code between two files, which is very, very silly, but there you go. Now we've gotten to the meat and potatoes, which is pretty much what you'd expect. We're close to being correct here, except there should be no new line afterwards. Except that's inconsistent with what if does for some reason. So let's have a look at that real quick. Oh yep, okay, that is actually really simple. The other ones just put a new line at the end. Cool. Okay, well that was a bit of a headache, but we have our tests running and we know that we can round trip this. Now if we break parsing our while statement in a very simplistic way, that will also break. Let's just do that so that it's at least different somewhat to the if test. Okay. We also need to implement all these other tests. I think only less than equal is implemented right now. Let me confirm that. Yeah, only less than equal is currently implemented. Okay, otherwise we panic. Otherwise we just blow up. That's very funny. That is very funny. Cool. So, we have a while, we just can't compile it. When we try and compile it, it says unimplemented. So let's try and implement it. What is a while loop, right? Well, a while loop, let me add another page to this wonderful document. Okay, a while loop. Let's draw this out. Let's go into my scene for drawing and let's draw this out. So we're gonna have while, ignore my horrific handwriting. Let's try and do that a little bit nicer. And for some reason, while, let's say x is greater than 1, x is going to be equal to x minus 1. Right? This is a while loop. And we're going to play compiler here and try and do this ourselves. So first off, we have the inner condition. This just needs to be something that we can jump to, right? So let's call this, let's write some pseudo assembly for what this might look like. So let's say label test, right? We want to do this test. So what do? We load let's say we load the address of x into our C yeah, we load the address of x into our C register, then we load C. So this is equivalent to saying register C is the value of x, right? Or kind of like saying it's the value of like the dereference of the memory address of x, because this is kind of how we have to do it in assembly land. Then we want to say, let's just say test C greater than 1. Now, if this is a horrible mishmash of things, if x is greater than 1, then we want to do the loop. So if this is true, let's say add if PC something. So if this is false now, so this is if it's true, then if it's false, we execute the next instruction where we're going to say set the PC to label out. Otherwise, we do the body of the loop. So let's shorthand this even more and let's just kind of say loop body. And then down here we say we set the PC to the address of label test, thereby jumping back up to here, right? Then down here we say label out, and this is, you know, rest of program, if you can read my writing. So here we jump to here, and in this case we want to add, we add 1 to the program counter, but this is actually ×2. So this jumps to here, which is the loop body. We skip 1 instruction. So this is it. This is all we need to do for a loop. And actually, this is somewhat simpler in a sense than our if statement, because there's no else to juggle as well. We've already done all of this stuff. Knight OCE is amused by dereference the address of X. But when you think about it, when you access a variable that doesn't just live in a register, it's kind of what you have to do, right? You have to get the address into a register somehow, and then you have to dereference it. So it you know, it's logical, but it's confusing. Excellent. So this looks like a roadmap that we can follow. So let's try and do it. Okay, so compile while. I really need to make this multiple files as well. I need to do a big refactor, but I might do that off stream. I might have to do that off stream. So let's make a block identifier as well. A block identifier, when we generate these labels, we can't just call it label test, because these have to be unique to the whole program. So what it'll actually be is, you know, some garbage 1, 2, 3 test, right? We need some garbage string that's unique across the whole program, and we have a special function that does that called gensim. Excellent. So we'll have a label test, which is going to be a new symbol. Excellent. Then we're also going to have label, we're going to have a label out as well. So this already looks a lot like our if statement. Symbol. This could also be cleaner, that's okay. Yeah, actually let's put a while in here too, so we know exactly what's going on. While label test, while label out. This one has to be cast to a string because this is a move, and this one does not have to be cast to a string because we're allowed to move because this is the last time we reference block identifier. Excellent. Excellent. Okay, now we compile the condition. We compile the condition, we append this to the output. Now we actually do the test. And let's actually just copy this. Let's copy this whole block, because it saves a hell of a lot of keystrokes. So we get the condition in the C register. Again, remember, we're doing the most inefficient thing possible for now. We get the condition into the C register. Everything goes through the stack. We do test. We see if C is 0. If C, yeah, that's correct. If C is 0, we add 2. So we skip over 1 instruction. Okay, maybe this is actually 2. Because if we just add 1, that just takes us. We add 2. We add 2. This was incorrect. This needs to be 2 times 2 equals 4, right? Because if we add 2, we end up here. We end up here. If we add 4, we end up here, which is where we want to be. Okay, excellent. Excellent, excellent, excellent. So step over the PC, but here, instead of jumping to the true condition, we want to jump label. Actually, wait, hold on. Label true. This is this double negative thing I struggled with last time. if C is 0, oh no, sorry, if C is 0, then this is falsy, right? So C 0 falsy. So if this is falsy, we if this is falsy, we leave the loop. C is 0. If C is 0, we leave the loop. So surely this is label out. I had this problem before. No, that makes sense. That makes sense. Does it? Yeah. If this is falsy, we skip over this. Hold on. Hold on. My brain, I can't handle it. I can't handle it. This is the inverse of what I wrote. So if C is not greater than 1, what do we do? If C is not greater than 1, what do we do? If C is not greater than 1, then we jump out. Otherwise, we do the block body. Yeah? Is that correct? That's correct. So we say out.append we compile the block. In an ideal world, we're going to create a new block here, a kind of a new scope that this is part of, but for now, it just lives in its own. Like for example, we can't declare a new variable that is local to the inside block of an if or a while statement. They're all function scope. They're all scoped to the entire function, which isn't ideal, but it does for the job for now. Then we add an instruction to jump to label test. Did I actually say this was label test? I did not. All right, yeah, because that doesn't exist here. So out.push unresolved instruction label. We put the label, what is it? Label test. Cool. And then down here, yeah, so we jump to label test and then we push label out. Okay, and that should just work, right? We're gonna build this, nothing's gonna go wrong. Nothing is gonna go wrong after we fix our parentheses, after we fix our other parentheses. Cond not found in the scope, that's fine. Cond, oh yeah, well that actually does make sense. Cond body, we just weren't binding the variables to anything. B, what's B? What is B? Where does B come from? Some B is else.body, so this is just actually the body. We compile, what function are we in? We compile the body. Nice, okay, we're getting there, we're getting there. Symbol does not implement copy. Label test. Move occurs, label test has type symbol. Ah, interesting, unresolved instruction. Label test.clone, label. So this needs to be label test.clone. That other one can move, but we're not going to do it for now. Excellent. So what happens when I build this? And disassemble it. Cool. So, I mean, let's just do the obvious thing here and copy it and then paste it into, oh, this has moved. This now lives at the index. Let's paste it into our VM, build it. Now let's step through and see what happens. We're going to jump into our main function. We do a test. Oh, I really need to be able to print this out with the labels intact. That would make this so much easier. So while one, what am I actually doing? While 1 is less than 2. So this should actually just loop forever. And that appears to be what we're doing. Or not. Okay, we ended up somewhere bad. We ended up in a bad place. Load stack offset. Okay, okay. Yeah, I guess this kind of makes sense. I guess this is kind of ambitious. Let's just try this. Let's just try this. Right? What happens if we just compile the dumbest possible if statement? Ah. Now that's interesting. Oh no, not code 16. See, what would be good is if we could just dump out the, let's do this. Let's just bite the bullet and dump this out, because it's going to make everything so much easier. So unresolved instruction defined here. Impl format display for unresolved instruction. Then we can dump this out with labels intact in a format that the assembler can actually still assemble, as long as it has the pretty printer enabled, or the preprocessor enabled, the other PP. Oops. I'm just going to copy the function signature from here because I can never remember what bits I need. Okay, so we're going to match self. So in this case, we just write the instruction, because instructions have a display implemented. I automatically generate that as part of my macro magic, which is cool. We have an immediate, a register, and a symbol. We write im s, right? So symbols are variables to get resolved at preprocessor time. Get an exclamation mark. Add im register symbol. This is the same. We just add immediate instead. Add im signed is even more similar again. Jump offset. And then label. Labels, in my example code, I always end lines in a colon, but in my actual assembler, lines start with a colon. Cool, so if I build this, it's gonna say something's gone wrong because we need to use std format. Now something still goes wrong. Symbol can't be formatted with the default formatter. Symbol can I do that? Can you derive display? Maybe not. Okay. We're just going to do this, and all we do is write f self.0. Cool, so now this works. Now let's go into our bin lang main, and let's add... Oh, it'd be great to do arg parsing. It'd be great to actually do arg parsing. So we get the code, we run the parser, dump ASM true, instructions, get instructions, map error, that's good. If dump ASM, then we want to that's not right. This one needs to be wrapped up in an else. At some point we'll do arg parsing and this will make more sense. Let mut.out equals out lock. Let what do I really want here? What I want to say, instructions, it's a vec of instruction. So let's say let instructions text equal instructions dot iter dot map. We want to turn it into a string, and then we want to collect that into a vec of whatever. Then we want to turn that from a from a collected vec of whatever, we want to join it so that they're new line separated. Right? Easy. Easy. Okay, so then stdout dot, can I stdout dot write? No, because there's no overloading. Rust stdout. What can I do with this, with a string? Or a structs, trade implementations, write. We can write a buff u8, write all, a slice of u8, we'll write, okay, so, let's, as bytes, that sounds good. Instructions, text as bytes. Let's see if we can do that. We can't, we have to map error. Okay, how does this look? So now if I do this, it looks like, I'm going to token if at while. Did I half do something? Expected token while, that's weird. Did I don't think I changed anything, right? Tests still pass. What did I do? That's not what I expected to happen. The unexpected token close. Huh. What have I done here? Okay, so that's good. Like, this literally worked a second ago. This is a bit troubling. A little bit troubling. While one. While a token and while a so it's unexpectedly finding the end. It's not expecting. Wait, is that because that's not? Weird. Why is it breaking now? Let's look at what exactly do I have here? Foo. Let's do exactly what's here. Foo equals bar. Okay, I'm a little bit lost. I'm gonna be honest with you all. I'm gonna let you in on a secret part of my vulnerability. Also, I haven't actually. Okay. I'm also just gonna do an audio check real quick. Yeah, good. Sorry, I had a couple of audio issues earlier, and was just a bit stressed because I forgot to do that. Okay, so well, let's make an exact test out of this case. So what do we have? Now, Rust strings are multi-line. So we can do this. And actually, I guess this is like a more complete test than I'm giving it credit for. Let's go into test. Lang tests mod, deep calls. Cool. We're gonna do this same thing. This actually checks the return value, which is cool as well. So let's go test. I mean, let's write a more sensible test anyway, right? That sounds kind of cool. So test main a equals 5 while a is less than or equal to 10. A plus 1, return A. And then A should be 10. A should be 11. Cool, okay, there we go. Parser. That's what we saw before. Okay, let's go up a level then. Let's go up a level, because that still doesn't really help us actually work out this parser error. That would be better suited in this file, where we will actually test the exact while loop that's giving us problems. While a is less than or equal to 10, a equals a plus 1, a plus 1. Okay, now this panics as well. Tag non-expected token. That at least is a useful error. This passes. So what about passing this in the context of a function breaks down? Oh, are you kidding me? This gets me literally every single time. I need to fix this. Currently, while statements need to have a semicolon at the end. Okay, now this is good. We can see that when we run this, we end up with the A register still being 1. So this suggests to me that I did get my labels backwards and we're never actually running the body of this loop. Let's see. A less than or equal to 10. A equals A plus 1. Return A. And then this needs a semicolon as well. This is literally the worst syntax decision I have ever made. Where are my labels? Where are my boys? Where are they? That's not what I want. Oh, because they're resolved. Oh, okay, hold on. Let's go back to our lang main. Can I do this? Alright, let's go deep. Let's do this unresolved. Okay, let's do this pub fn get lines unresolved. Yeah, we can do the same thing, but instead of this, we're gonna get the instructions. For each instruction, we're just gonna say ins.toString. And I think we can just say out.push ins.toString, because if it's stringable, this will just work. For each instruction in the function, we're going to out.push ins.toString and return out. Okay, so now we're going to go a step deeper. So this goes here. We're going to say instructions text is res.get get lines unresolved. This is a bad name, but that's okay. This is really bad error handling, but that's also okay. And we're just going to say dot join. Now what happens? Oh, okay. Compiler errors don't implement display. That's okay. Let's try this again. Nice. Okay, this is better, right? This is better. So this is something we should be able to assemble with our pre-processing assembler, where these labels and whatnot will get resolved. This is our garbage, absolute garbage that marks our labels. So let's copy this. Let's copy this and see if we can build this in my simple virtual machine, which is becoming less and less simple by the day. Build. That looks good. Reset. That looks really good. Now, one thing I was trying to do with this, right? And for some reason it doesn't work. But if we go to index, if we go to index.html and we go to not calculate frames, there, assemble, ASM, and upload. If line, blah, blah, assemble line. Oh, hold on, no, this one. So this should handle these lines, right? This should handle these labels. Code lines. Oh, except, yeah, the preprocessor strips these out. Of course it does. It leaves no labels behind. Let's try putting the assembly in here instead, and see what happens. And of course that breaks. That blows up in a lot of ways. Line 8, uncalled error in line 8. Update code view. Wait, where does this come from? This comes from the... How does that change the... Let's try that again. Let's paste this in. Let's hit build. Okay, so what's the cool stack here? .resolve. Oh, maybe actually there is a problem with this assembly. 0, 1, 2, 3, 4, 5, 6, 7, 8. What does our preprocessor have to say about this? Okay, what does it have to say? We've got the whole macro part. Yeah, if it starts with a colon. So why does this break? Why does it not like... Why does it... We have a preprocessor, right? This is what the preprocessor does. It resolves. Resolve. It does this. It does this syntax. Uncaught. Where does this error come from? Ah, that's more interesting, isn't it? 168. Sorry, WASM 168. Error at line 8. Now this error can't be formatted as a string, I'm sure. No. Well, okay, what the hell's this? Wait. I don't know where this error has come from. It's really snuck up on me. Get random? Like what? What is going on? Why suddenly has this popped up? IMP, like what? Is that like a cargo? It's like a cargo update? Doc init add. Let me just cargo update real quick and see if this fixes it. Make WASM. Okay, well we can't rebuild the WASM right now. That's okay. And that's okay. We don't need to. We don't need to. It would be nice to step through and see what's going on here, but I don't want this to become the stream. So we're going to go back to our language test, and we're going to make T. And hopefully this still builds. That's actually a dangerous update to do. Okay, so let's go back to our compiler, and let's swap the branches, because while... This is probably it. It's probably the same thing we did before. It felt a bit weird when I did it. So we do the test. If so this is here we're saying that we want to just that means we need another label. Hold on. I think I have a either non-zero. Where is test op defined? Either non-zero. So if C is non-zero, okay, let's try this. That passes. That bodes well. I'm gonna have to run to the bathroom quickly, and then we're gonna think. We're gonna engage our brains. All right, that was nice and quick. My energy is actually starting to crash a little. I might write a couple of more tests for this and make sure it works properly, and then call it a win, right? Because this is a pretty good win. This is a very good win. We have while loops, and they're cooking. So let's write a test for a nested while loop. Okay, so we'll say let int b equal 1. While a is less than 10, b is less than 10, how can we do this in a way that we'll let int c, which will be 0, c, right? So we'll increment c. This should be, and then we'll return c. So this should be, once I put a semicolon here, which I don't love, what is it, 99, right? Because I start at 0. 10. Huh. Okay, so we have a problem. We have a problem. And it's really hard to work out what that problem is. While oops. Left. So it's saying that the A register, it's saying that C only ever gets to 10, which I suspect means that somehow we're not jumping back to the correct loop body, or we're not doing them the correct number. It feels like we're only doing one iteration of this. 0, 1, 2. Oh yeah, and it's less than equal. So let's do just, well, we can't do strictly less than. We don't have strictly less than implemented yet. Okay. So what the hell is going on? I really need to be able to see what's happening here. Okay, so I'm gonna do something real quick. And then this is probably gonna freeze for a little while for some reason, because this always happens when I try and pause my Eskinema recordings. Okay, so what is going on? Unknown targets, enable the JS feature. Get random. But where does get random come from? What depends on get random? So let's look at cargo.lock, get random. Okay, so this is actually part of... But okay, hold on. Let's see if anyone else has had this problem. Someone else surely has Googled this before. Yep, that's it. It's just weird because this came out of nowhere. Let me make this bigger so you can read it as well. Error, leaking SP runtime, leaking STD, yeah. So what did I add other than surd? Let's see if... is there a way to list the features? There is. Derive. Oh, that's really annoying. Oh no, hold on. Wait, is it this? Can I... Is it this random dependency? I bet it is. That would make sense. So what if it's rand... Aha. Rand. Where's crate rand? Crate page, features. Ah, okay. So let's build it without STD, right? So default features. I don't know, I must have not had this in the branch somehow. I must have only just merged this in. Default features, WASM support. Not automatically supported, use a different target. Get random JS feature. Okay, get random with the JS feature. So, I mean, here's the other thing, right? Here's the other thing. Lang. We should only really care about any of this. Oh, why? This is only required for this one binary. Okay, here's what we need to do. Here's what we need to do. we're gonna go into cargo.toml and we're gonna see if we can set this to not have default features. And see if we can build. Oops. Version. Otherwise, we're going to have to refactor this as, of course, thread RNG. I don't know if it does. Get random. Emo Giraffe 450, welcome our viewer from Egypt. That's really exciting, and thank you very much for the follow. I hope you enjoy me looking at Rust docs to try and work out what's going on. No, it's wonderful. It's wonderful. Get random. Okay, you know, I just have to bite the bullet and do it. I really do. I need to have different dependencies for these. So, thank you. I hope you're having a lovely day as well. What's the weather like in Egypt at the moment? It's very cold in Melbourne, but I'm getting by. Is this GNU Linux? This is Arch Linux, but it's my very customized Arch Linux, which, you know, this is kind of how I roll. Keep everything very lean. I'm using DWM as my window manager and ST as my terminal. Well, actually, no, I'm using Alacrity as my terminal, but I usually use ST when I'm not streaming. Alacrity just has some nice features, and it's easy to make it big. Okay, so cargo.toml workspace. So I need to make another directory. Surely there's a better way to do this, right? Cargo build was. Here's another thought. I'm really trying to avoid doing the work, right? Because I just shouldn't need to build them. While the temperature's 40 to 45, that is hot. Even by Australian standards, that is hot. Man. Yeah, good luck. Good luck. Hope you have some good aircon. Target. Some targets, yeah. This is what I want. This is what I want. Yep. Intend to run standalone exe. WASM. Let's put as libs. 2 target platforms. Blah blah blah. Lib necessary for WASM to work. Target.cfg.lib. That way you can make a target with specific dependencies. Wait, can I do this? That still doesn't work somehow. Wait, okay, that's annoying. That's really annoying. It's rejected. Cargo didn't want to encourage this pattern. Cool. Okay, so I have to make it a workspace. Auto bins. Nice. Linux Mint is a really good place to start. That's what my dad uses. It's what I always play around with when I'm at his place. Issue. Okay. libvs bin. 5 years after that, and blah blah blah. Features.lib. Yeah. Lib. See, why this thing that I depend on? Okay, I'm gonna think. I'm gonna use my brain. I'm gonna use my brain here. Maybe I just have to bite the bullet. This will actually still be a problem though, right? This will still be a problem even if I do the workspace. This will, because, that's absolutely maddening. Let's plug into the cargo. That's okay. This isn't quite what I want, I don't think. I need a way, well, I guess I just need, it's really unnecessary, right? What's unnecessary is this one binary target needs this dependency, but you can't have cargo binary target specific dependency. I guess the lang should be its own. Workspace would fix this. Workspace would fix this. Oh, bugger. Let's try making this a workspace. This was a bad commit. Let's leave that for now. So we're going to make a directory called VM and we're going to make a directory called lang. We're going to move cargo.toml into VM and we're going to move source into VM. We're going to clean up a few of these things as well. fib.prog, we're going to remove a, we're going to remove a.bin, we're going to remove call.bin, we're going to remove fib.bin, we're going to remove, what's foo? Remove foo. pp.asm, we can remove. Maybe we should keep this as a test. I don't know. Okay, we're going to move cargo.lock into VM as well. Okay, so cargo init cargo workspace help. What do I think of systemd-less distributions? I think it's a cool idea. I think systemd should not be Linux. I think that's, bad. I think that kind of stinks. But also, I find it very convenient to use systemd for things. So I think it's good. It's important that people continue to develop Linux without it, but it's also kind of useful. There's more to Linux and systemd. I hope that will always continue to be true. I encourage people who want to step outside of that world. Okay, so add. Okay, cargo.toml, so it'll be like this. Add members to the workspace. Nice. Cargo new. Yep, excellent. Excellent. Add a 1. Cool. So now let's move things from VM source bin lang. We're just going to we're going to make a directory first. We're going to make lang source. We're going to move VM source bin lang to lang source. Wait, that still wasn't right, was it? Move everything from lang to here. Okay, perfect. This is hopefully good. Cargo init bin. Okay, so cargo.toml. I thought that's what we did. Binary application template. I thought I did that. Edition name. Let's just go. Yeah, it just has source main, which is what I have as well. That's kind of weird. Let's just, if I lang, that's very weird. Why doesn't this work? What's going on here? Manifest for workspace member VM. Oh, no? Yeah? So we walk up a directory. Ah, we need to get rid of this line. Sorry, my apologies. Oh yeah, also this. Okay, I think this is good. We're making progress. This is good. This is good. Now, we don't need this dependency here anymore. We only need it lang. Yeah, so let's go back here. We're in a different directory, lang cargo.toml dependencies. This requires we go to lang cargo add rand. Okay, there we go. Now, how do we do our perfect? That is actually super simple. Cargo.toml dependencies simple VM, and path is ... VM. That is beautifully simple. Now everyone's happy. Everyone's very happy. Cargo. Can I do this? I can do this. Test.code. And I can pipe this into cargo run bin dis. Excellent. This is working beautifully. Apart from the fact that it's like, broken, but yeah, other than that, I'm pretty happy. Oh, that's because we're just printing it out. That makes a lot of sense. Okay, excellent. Excellent. We're doing well. We're doing good things here. Good things are happening. Okay, so we're gonna add lang, we're gonna add VM. This is a big old folder. New file. Sure, that added a bunch of stuff I actually didn't want to add, but that's okay. And then we're gonna git add cargo.toml git. Oops. We also want to get rid of VM lib macros target. We don't want that. What's going on here? New file target. We don't want this. We don't want this. Okay, so we renamed. This looks good. All the length stuff moved to a different path. Cargo.lock, this is good. Macros, yep, that looks fine. Renamed all of our source files. They now have a VM prefix. That looks good. Excellent. Okay, now we're cooking. And that all looks good. That all looks so good. So perfect. Okay, this did not feel like it needed to be part of our while loop work. However, now we can go into our lang main. We can toggle this, which is going to be an arg eventually, but for now we just do it the dumb. Actually, no, wait, hold on. Let's not do it that way. Let's go back. Let's cargo run lang binary. Let's run it on test.code. Let's xclip. Copy this. Let's make wasm package. Let's do this. Cool. I think this makes a bit more sense. Doesn't understand this. When was this last edited? That was like now, right? Perfect. So if I go back over here, I reset this, I build this, something goes wrong. Internal main local count unknown token. Okay, now we can go back to editing. Internal main local count. Oh, this token isn't real. Okay, we can't do this. We can't do this unless we say, how do I define this stuff again? What's the macro called? Defvar. Alright, so now if I build this, it does work. Except it doesn't work. What the hell? Okay. You know what? You know what's a better idea? We go back to our... Oh yeah, our main. That's right. We just go back to compiling this the old dumb way. We cargo build this. We pipe it through our cargo bin disassembler. Now we come, we paste this in here. We build it. Hold on. Okay, we git check out www index.html because I obviously really messed something up badly there. Now we build. Now we have instructions. Now we're back working with instructions. And we're going to see what happens when I do this while loop. We step, we do stuff. 10, we push, blah, 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 we compare. Either non-zero. We skip over an instruction. We keep going through the loop. We go back to the top. That's cool. So we can kind of see this happening in real time. We see 2 becomes 3. We do our test again with 3, blah, 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 blah. That's cool. So what if I go to test.code and I do what I was doing, right? So we have A, we have B, and we have C. Let's make them 0 this time. While A is less than 2, A plus equals 1, while B is less than or equal to 2, B b plus 1, and c is going to be c plus 1, and then we're going to return c, and we need a semicolon. Okay, so, oops, didn't mean to do that. We end up with an unknown opcode, which is interesting. Let's see what happens here. Unexpected token, okay. That, it looks okay. Maybe it's because of this. No. And I honestly feel like I'm running out of steam a little bit here. My brain is turning a little bit to mush. So we might leave it there with while loops broken, but a lot of good progress today. I think this has been fun. I think this has been enjoyable. I think we've done some good stuff. We've had a couple of people hanging out, so thank you everyone who has come in and watched. It's been a partly productive stream. We'll call it that. We'll call it partly successful. While loops coming together, we're gonna do some fun inline assembly stuff. We're gonna start playing around with different kinds of memory. I'm gonna write an optimizer at some point that actually does things in registers, because at the moment all of the stack messing around is a little bit inefficient for my tastes. So thank you very much for tuning in. My name's Tom Marked. If you enjoy this, feel free to follow me, subscribe to me, support me on my Ko-fi page. Thank you to everyone who watches these videos through to the end. I can see there's a few of you out there. And yeah, I really appreciate any comments people leave with Rust advice, life advice, anything. Please reach out and say hi if you've enjoyed this video. So thank you so much. I'm Tom, and I'll hopefully see you next time.